All right, so in this video, I want to go over a really cool process where we can use what we've learned about equivalent equations and creating equivalent equations, along with a strategy to essentially remove fractions from our equations. For me personally, I think that if I can remove the fractions from my equations, it makes them easier to solve. So just as a little reminder, there are four properties of equality that we've talked about. Four things that we can do to both sides of the equation that give us another equivalent equation. If we solve an equivalent equation, we'll get the same solution as if we solve the original equation. So here they are right here. We can add the same thing to both sides. We can subtract the same thing from both sides. In both of those cases, we're just combining like terms. We can multiply both sides by the same number, and we can divide both sides by the same number. In both of those cases, multiplying and dividing both sides involves the distributive property, which means we have to multiply everything or divide everything on that side by the number. So we talked about four different strategies that we could use where we're utilizing those properties of equality to solve an equation. And I usually approach my strategies in this order. First, I simplify the left side or the right side, or both, by distributing or combining like terms. Then I try to get all of the variable terms, all of the x's, for example, on one side of the equation. And I can typically do that by adding or subtracting some number of x from both sides. Then I try to get all of the constant terms on the other side. I want just the variable parts on one side and everything else on the other side. And I can usually do that by adding or subtracting. And then last, we figure out the value of one variable by multiplying or dividing so that we get 1x or 1y or whatever. Well, there's another strategy. We could kind of look at this as another way of simplifying, I suppose. But this is the strategy that I can use to get rid of fractions in my equation. This is an awesome strategy. I think that you'll find it to be really, really useful. I'll go over the four steps here, and you probably have these copied down in your notes already from class, and then we'll do an example here in a second. So the first thing that I want to do is I want to figure out what my least common denominator is going to be. If I've got more than one fraction in the equation, I need to find a common denominator so that everything in my equation can have the same denominator. Then I need to make sure that every term is written as a fraction. So if I have a whole number or an integer, I'm just going to put that over 1 so that everything is a fraction. Then I'm going to make sure that I give every fraction the same least common denominator. So I'll have to multiply both the top and the bottom of each fraction by something so that they all share the same least common denominator. And then finally, technically what I'm doing is multiplying both sides of the equation by that least common denominator, and the effect is going to be that all the denominators, the bottoms of the fractions, just disappear. I think when we go through this process, it'll seem even easier than reading through these steps. So let's try a problem here. So I've gone ahead and written out a problem for us to try here. And the problem is I've got 2/3 x plus 5 is the same as 1/6 x minus 1. So those two expressions can only be equivalent if x equals one particular value. And we've got to figure out what is that value. Well, first of all, we know that there are two ways that I could write 2/3 x. I could write it as 2/3 x, but I prefer to write the x up in the numerator with the 2. So I'm just going to rewrite this. And I'm also going to, while I'm at it, right? Everything is a fraction. So I've got an integer here. I'm just going to write that over 1. Here, I'm going to put the x up in the numerator. And I'm going to write this integer as 1 over 1. We haven't really changed anything yet. We've just rewritten it a little bit. Now, we're going to write an equivalent equation that has the same least common denominator. And let's see, I've got denominators of 3, 1, and 6 now. My least common denominator is going to be 6. So, in order to change this fraction to sixths, I'm going to multiply by 2 over 2, which gives me 4x over 6. Now it's got a denominator of 6. In order to give this a denominator of 6, I'm going to have to multiply by 6. Of course, I have to do the same thing on the top and the bottom. So that gives me 30 over 6. This one already has a denominator of 6, so I'm good there. 1x over 6. And here, if I want to give this a denominator of 6, I'm going to multiply by 6 over 6. That's subtraction there. So now I've written an equivalent equation where everything has the same denominator of 6. Well, the beauty of this is that if I multiply everything by 6 now, and I'm just going to temporarily write this in. If I were going to multiply both sides by 6, I'm going to have to distribute to do that. Then when I multiply 6 by 4x over 6, my 6's are going to cancel out. And I'm just left with 4x. If I multiply 6 by 30 over 6, multiplying by 6 and dividing by 6 cancel each other out, and I'm just left with 30. If I multiply this side by 6, if I multiply 6 times x divided by 6, multiplying by 6 and dividing by 6 cancel each other out, and I'm just left with x. And same thing here. If I multiply by 6 and divide by 6, those are inverse operations. They cancel each other out, and I'm just left with minus 6. So usually when I'm solving these, I don't even write this part out necessarily. Instead, as soon as I get a common denominator, I can just drop the denominators. And I'm just left with 4x plus 30 equals x minus 6. Now, this is an equation that's much easier to solve. So let's just go through our regular strategy for solving this. I want to get all my x's on the same side. So I'm going to remove the x's from this side by taking one x off of each side. That leaves me with 3 x's over here now. I still have this plus 30. And I don't have any x's over here, but I do still have that minus 6. All right. Now, I want to get all of the constant terms on the other side so that the x's are all alone. So I'll take 30 away from that side, and whatever I do to one side, I have to do to the other. That leaves me with just the 3 x's over here and a negative 36. All right, I'm almost there. I know that how much 3 x's is worth. I'd like to know how much just 1 x is worth. So if I divide both sides by 3, that gives me 1x having to be equal to negative 12. So that is the process by which you can get rid of all of the fractions in your equation. I hope you find that to be super useful.